In a previous lecture, we talked about text mining and gave some examples from machine learning and deep learning using techniques in scikit-learn to perform classification. We discussed classification algorithms and how they could be used for tasks in natural language processing like sentiment analysis, spam detection, topic categorization, and so on. And we looked briefly at some clustering algorithms as well. So for classification, if you have labeled data, you can train a classification model to classify new data. And if you do not have labeled data, you can use an unsupervised clustering algorithm applied to your data instead. Now we want to dive deeper into the classification techniques for natural language processing. We'll follow this link to classification algorithms. We'll start with a quote from Gemini. Classification in NLP is a fundamental task that involves automatically assigning text data into predefined categories. Imagine a system that can analyze a news article and label it as sports, politics, or entertainment. This is the essence of NLP classification. Utilizing machine learning algorithms, these systems can process vast amounts of text, identify key features, and assign appropriate labels, enabling applications like sentiment analysis, spam filtering, and topic modeling. This powerful technique plays a crucial role in organizing and extracting meaning from the ever-growing ocean of textual information. In this image, I have listed some NLP classification techniques, and we start with feature extraction. Feature extraction is a group of techniques to take your input text and extract features from it that can then be compared. For some NLP terminology, count vectorizer is a technique for converting text documents into numerical vectors based on the frequency of word occurrences. Hashing vectorizer is similar to a count vectorizer, but uses a hashing function to map words to numerical indices, potentially reducing the memory usage. Word embeddings are numerical representations of words that capture semantic and syntactic similarities, and they capture contextual information about the words. TF-IDF stands for Term Frequency Inverse Document Frequency, which is a weighting scheme that assigns weights to terms in a document based on their frequency within the document and across the entire corpus. Part of speech tagging assigns grammatical labels like noun, verb, adjective, etc. to words in a text. Bag of words is a text representation where documents are represented as bags of words without considering the word order or grammar. And bag of n-grams is an extension of bag of words that considers the sequences of words in grams, so a sequence of n words instead of individual words, which does capture some sequential information. These are different feature extraction methods that can be applied prior to applying different machine learning algorithms or deep learning techniques against those features for tasks like NLP classification. In supervised machine learning algorithms for classification, we might use support vector machines, KNN, naive Bayes, decision trees, random forest, or XGBoost, and we'll look at these in a moment. Or we might, of course, use deep learning techniques applied to the problem as well, like convolutional neural networks, recurrent neural networks, or LSTM algorithms, and we'll outline some of these techniques here as well. Looking at common NLP classification techniques, there are some common techniques that we use, and the choice of the technique is dependent on various factors like the size of the data, the nature of the data, the desired level of interpretability, and the computational resources that are available. For rule-based classification, we could use simple keyword matching, where we identify documents containing specific keywords or phrases. This is a simple method, but it is very limited. If you think about any time you are searching, for example, a web page or a document for a specific keyword, this is the level of classification that we're doing, simple rule-based keyword matching. We can improve on that with regular expressions. These use patterns to match to specific text formats, which is more flexible than matching a specific keyword. For example, this is a regular expression in Python that is going to match to all words that start with the capital letter T. If you're not familiar with regular expressions, they are used across multiple programming languages. I put a link here to Python regular expressions for specific syntax when you're creating a regular expression in Python. Here's a tutorial on W3 Schools where you can learn how to build a regular expression for use in Python and how to use the regular expression module that's available in Python. And we see there are 4 functions associated with that module to search for matches using a regular expression, and the meta characters that have special meanings that allow us to build up these regular expression strings. And you will find that while Python's syntax may be slightly different in some instances, in general there's similarities across regular expressions and how we define and build them across different programming languages, and what the different sequences mean. For example, in the example that I provided where a word starts with a capital letter T, we used /B to return a match that specifies characters at the beginning or end of a word, and we put it at the beginning. We also used the special /W, which returns a match where the string contains any word characters, which includes A to Z, digits 0 to 9, and the underscore character. And then we followed the /W with a plus sign, meaning 1 or more. And if you scroll down through this tutorial, you will see an example a little further down than I thought. Here we go, where we are matching words that start with a capital letter S. So this is similar to the string I created, words starting with capital letter T. And you can try this yourself and work on building regular expressions to improve search beyond simply searching for a specific word. That defines some rule-based classification methods. Now, we want to improve on that if we have the resources available to us, and we can do that with machine learning classification by using supervised learning approaches from scikit-learn, which is our machine learning library for Python. And if we go to the page here, we've looked at this before, and you'll see that you can click on classification and find the supervised learning techniques. And you'll notice in here the techniques that are pointed out at the Tanya AI site. For example, support vector machines, nearest neighbors, naive Bayes, and decision trees. The question then is, what do we do with machine learning classification algorithms in natural language processing? So here we'll cover some example methods and potential use cases as this classification approach applies to natural language processing tasks. The first one looks at naive Bayes, and we could use that for classifying documents based on word probabilities and their independence assumption. So this is a simple classification, but it will be efficient for some tasks. An example of this class, classifying documents simply based on word probabilities. Support vector machines, another classification algorithm. We could use this to find an optimal hyperplane to separate different classes in a high-dimensional space. And so anytime we have high-dimensional data, support vector machines would be efficient or effective for this. And we see this a lot with text data. We could use decision trees to classify documents based on a series of yes-no questions about the features. This is highly interpretable and good for handling things like missing data. We could use random forests, which combines multiple decision trees to work towards improving the accuracy and robustness of those machine learning models. And this is a popular choice for a lot of classification tasks. K-nearest neighbors, or KNN, we could use to classify documents based on their similarity to other labeled examples that are provided. This is, again, simple but effective for some tasks. And then finally, logistic regression can be used to, for example, model the probability of a document belonging to a particular class, which is interpretable and good for binary classification problems. The first thing you might ask yourself if you wanted to apply a machine learning classification algorithm to your problem, how do you choose an estimator? And scikit-learn provides an interesting chart that you can use to choose your estimator. So we talked about classification and a lot of different methods. We've mentioned clustering previously, and we briefly mentioned regression, and we talked about high-dimensional data where you might want to do dimension reduction. So which of these algorithms would you want to choose? A good way to get started in looking at this is to follow this algorithm cheat sheet. So you start by asking the question, how many samples do I have? If you have greater than 50 samples, then we continue. If you don't, well, then go get more data because you don't have enough samples to really do anything. If you have more than 50 samples, the next question is, are you trying to predict a category? Well, in classification, we are trying to predict a category, so we're going to say yes. Do you have labeled data? So we talked about supervised and unsupervised machine learning algorithms. Supervised algorithms require that we have some pre-labeled data that enables us to train the model based on that labeled data to do predictions, to assign the classification labels to new data. And if we have that labeled data, we follow this yes path, and that gets us into the classification algorithms. And from there, you can continue asking the questions, how many samples do you have, and so on. And of course, if you don't have labeled data, then you are most likely going to want to apply some form of clustering technique. In addition to machine learning, again, provided we have the resources available to us, we may want to apply deep learning techniques to our classification problem. Here I have added links to several deep learning tutorials specific to text classification. The first one is a TensorFlow tutorial for basic text classification. And you can walk through the tutorial, run it in Google Colab, or download the notebook. And the example they use is sentiment analysis, which you're going to see is a commonly used example. The next link is to PyTorch and Torch Text, which is a library in PyTorch that is used for text classification. Follow the tutorial there, which again has a notebook that can be ran in Colab or downloaded. And if I recall, this one is doing sentiment analysis as well. Actually not sure on this one if I remember specifically what classification task it's doing, but you can follow this tutorial if you would like to do text classification in PyTorch. Finally, you can use the spaCy text categorizer. So remember spaCy being a library, a Python library that's very useful for natural language processing tasks. And there is a text categorizer component where you can train a model to categorize text. There's a tutorial that you can walk through here, and this can be used for multi-label classification or simply binary classification as in true-false. So again, what are some example methods and use cases for the deep learning techniques? So we can use, so each of these is using artificial neural networks, sometimes convolutional neural networks, sometimes recurrent neural networks, and sometimes long short-term memory or LSTM. In CNNs, these are effective for tasks that involve sequential data, which text is frequently sequential. And these are often used for the sentiment analysis tasks. Recurrent neural networks, or RNNs, they can handle sequential data and dependencies between the words. So again, useful for tasks like text classification and sentiment analysis. And then LSTM, which is a special type of RNN that excels at capturing the long-term dependencies in the text, which again is often used for sentiment analysis. And we've also seen this a lot in other lectures in this series, using LSTM for machine translation. Other techniques include ensemble methods, for instance, combining multiple classification models to improve the performance. In scikit-learn, under the supervised learning section, there is a tutorial on all of the user guide on all of the ensemble methods available: gradient boosting, random forests, bagging, voting, and stacking, and examples of how to use each of those, so usage for the different algorithms there. And in addition to ensemble methods for machine learning, making improvements there, we can also use transfer learning. So this is utilizing models that have been pre-trained on large data sets to try and get them to transfer to improve our performance on new tasks. And we can even fine-tune these models for better accuracy on those specific tasks. And we've looked at these before again. Hugging Face, where I have linked to a tutorial on text classification. And you can use Hugging Face models as is to perform text classification. There's a YouTube video here from Hugging Face. And the use case they look at in this tutorial is, again, sentiment analysis. And this is sentiment analysis across customer reviews for tracking sentiment of your customers and your products. There are also spaCy models. So we looked at spaCy text categorizer, where you would train your own model to do the categorizing for you, the classification. spaCy also has pre-trained models. So classy classification on spaCy, this is gives you the ability to use spaCy with pre-trained models in the case where you don't have the time or the resources to train your own model to do your classification, you can use spacey models. Now, I mentioned sentiment analysis often as an example of classification and natural language processing. And of course, many of the tutorials that I link to on this page use sentiment analysis as their example for performing classification. In sentiment analysis, we're given some text and we want to determine if it has a positive, negative, or neutral sentiment. So we want to classify the text into one of these categories, or we want to, in the case of regression, give it a score based on the percentage that it fits into negative versus a positive scale. This is a very popular technique in looking through social networking posts for social research. And there's business use cases we mentioned where you might want to look at emails or customer chats, maybe to triage your customer service communications. You also might want to look at entire documents like news articles to identify which ones have a more positive spin versus a negative spin. Let's look at now some online tools for sentiment analysis. I don't think I have a link to it on this page, but if we go back to the prior page where we got to this one, all right, there is a link to a sentiment analysis page on the same site. And our quote from Gemini: in the realm of natural language processing, sentiment analysis is a powerful tool that unlocks the emotional undercurrents of text data. It delves beyond the literal meaning of words, aiming to classify the sentiment expressed as positive, negative, or neutral. This allows us to gauge public opinion on social media, analyze customer reviews, or understand the overall tone of a news article. By deciphering the emotional sentiment embedded within language, NLP empowers machines to make sense of the human experience in a nuanced way, opening doors for more empathetic and insightful applications. On this page, I have shown some examples of processing a sentence. Of course, the quality of sentiment analysis can vary considerably, and we'll see how it varies across the tools, just a few tools that I've looked at here. And we start to see a significant variance across different tools with sentences that are difficult to gauge the sentiment of. For example, sarcasm. Sarcasm requires a deeper understanding of a language and looking at statements in a broader context. It also helps if you have familiarity with the speaker, which is something a natural language processing model will likely not have. Of course, then a model can be fine-tuned for further familiarity with a speaker, given that we have the text available to do that fine-tuning. So below, I will show the outcomes of testing a negative sentence with sarcasm using 5 different methods. So I just randomly chose 4 online tools for this. I think it was just the first 4 that came up in a search for online tools. And then I provided a simple natural language toolkit code example. And in this case, I made it exceptionally challenging because there's no context to the input sentence. So the input sentence says, "I just love standing in line." Now, an English speaker might recognize that as sarcastic because typically people do not love standing in line, and saying, "I just love it," may come across to an English speaker as a sarcastic sentiment. So let's see how the sentiment analysis tools that I chose classify the sentiment of this difficult sentence. The first tool is a screenshot of the tool where I put the sentence in, and the analysis came across as positive. There's a link to that. So this was a rating of positive with 60% polarity, so not strongly positive. And there's a link to the tool I used here if it's still available, this text processing demo. I haven't checked these links to see if they're still available. I did this test a while ago. But you will find tools like this come and go, appearing online for a while and then sometimes disappearing. Here's another one that was available when I created this page, a free sentiment analysis demo, and a screenshot of what that page looks like. Again, I put in my same line, and this time I got positive with a magnitude of 58%. And of course, the word love is going to be making this particularly difficult because that's typically associated with a positive sentiment. But the rating positive of 53% does state that in this case the model was not certain. The sentiment analyzer, the next tool I found online, put in the same sentence. This one I got a positive rating with a confidence of 97%. And then finally, the last one gave me a negative rating of 100%. So you see a significant difference in the different models. Of course, I did not investigate what these online tools were using on the back end. But I went ahead and created a simple script using NLTK to see what that came up with for a sentiment rating, and the rating was positive, but again at 51%, so uncertain. And this is simply using the sentiment intensity analyzer that comes with NLTK. Now, of course, we looked at a lot of different technologies, and I showed you a lot of different tutorials where you could actually train a model to do sentiment analysis or fine-tune a pre-trained model to do sentiment analysis. And you can try to get a better result from that. Another thing we can do, let me copy this sentence. We can hop over to Hugging Face and look for models that are made for classification. For example, text classification. And I may want to specifically filter to models that have sentiment in the name. So looking for models that do classification but might be fine-tuned specifically for sentiment analysis, and then I do see models coming up with sentiment in their name. And we'll just go to the first one on the list here and see if it's available with an inference API, and it is. So I can test this online by putting my sentence in directly and clicking compute. And again, I see with this model, I'm getting 94% positive, so it's not recognizing the sarcasm. The next thing I might want to ask then is there a model that was already fine-tuned for sarcasm? So I'll just look for sarcasm. And I do see some models that were fine-tuned from base models, presumably for sarcasm, because I saw sarcasm. So sarcasm detection is in the name, so this probably does some kind of sarcasm detection. The inference API is not available as this model is not as does not have enough activity. However, I could use this model and use the transformers library by simply copying this code, and then I can run this in my Colab notebook, or I can run it locally in a Python file and use the transformers pipeline to test the model on my sentence, or I can load the model directly if I wanted to then do further work with it, so importing the tokenizer and the model for sequence classification specifically for this model using this code here. And then I could test these sarcasm models and see if I can get a better response. Let me sort this by most likes, and we'll see This one has a lot more use, but still not enough. So 3,400 downloads, but still not enough activity to be deployed on the inference API. So again, if you want to use the model, you will actually need to copy this code and run it in your own Python script or notebook. So this points to a lot of different ways that we can begin to evaluate different sentiment analysis techniques. And of course, following the tutorials linked to from classification and natural language processing, any classification algorithm is going to be able to perform, to be train a model to perform sentiment analysis. That is an introduction to natural language processing, classification techniques, with sentiment analysis being one of the more commonly used techniques for this. And we, of course, mentioned some others as well. And you can find different tutorials online talking about how we can perform other natural language processing tasks using classification.